All right, ladies and gentlemen, welcome to today's video lesson. Today we're going to talk about Kramer's rule, and we're going to go over two quick examples. Now, I took the liberty of writing a couple of the explanation and a couple of problems, and that way it'll make it quicker, so that way we can get through this as quickly as possible. So Kramer's rule it was invented obviously by a Swiss mathematician whose last name was Kramer, and it's used in solving systems of linear equations by using matrices and determinants to be more exact. So we're going to look at Kramer's rule for a 2 by 2 matrix, and then we're going to see a real quick example, and then we're going to do the same for uh, a Kramer's rule when you have a 3 by 3 matrix. So for a 2 by 2 matrix, if we have a system of linear equations such as ax plus by equals e over cx plus dy equals f, we take the coefficient matrix, which is basically the coefficients a, b, c, and d, which are the number part of a variable, and then we find the determinant. For example, if we have we find the determinant of the coefficient matrix of a times d minus c minus b. And then we basically take the coefficients of the other matrices. So we take the coefficient of E, B, F, and D over the determinant of A. And then we take the coefficient of of A, E, C, and F, and find the determinant of and find that determinant as well in order um, to find the answer. And that's how we get our ordered pair in this case. Okay. So we have an example here. And this example, we have the system 9x plus 4y equals negative 6 over 3x minus 5y equals negative 21. And let me fix this so that it looks more like a negative. Give me a second. So it looks more like a negative 6. Okay, so let me go ahead and change the color. And I took the liberty of starting the exercise. So whenever you have a system of linear equations, specifically, and you have two equations where you're going to get 2 by 2 matrices, it's always good or helpful to label them. So I know that this is A, B, C, D, and of course this would be E and F. So the first thing we're going to do is find the determinant of the coefficient. So that would be to find the determinant of the coefficient matrix, which is A, B, C, and D, which in this case would be 9, 4, 3, and negative 5. So I'm going to find the determinant of this coefficient and negative 5. And then basically to find the determinant, reviewing the last video, was basically multiply, in this case 9 times negative 5, which is negative 45, minus 3 times 4, which is 12. So 3 times 4, which is 12, and negative 45 minus 12 equals negative 57. So we have the determinant of the coefficient matrix. Now, what we're going to do is just plug in the numbers into the variables. So let's see if I can move this over here. And we're going to solve for x. And instead of saying x equals E, B, F, and D, we'll say x equals, the matrix would be negative 6, negative 6. It would be 4. It would be negative 21 and negative 5. Negative 21 over negative 5, and we divide that by the determinant of A, which was negative 57. So what we're going to do is we're going to find the determinant of this matrix of the negative 6, 4, negative 21, and 5, and then we're going to divide that over negative 57. So again, we're going to find the determinant of this matrix and divide that answer by 57. So if we do that, we simply say, in this case, we multiply 6 times negative 5, which is 30. Negative 6 times 5, which is 30. Negative 6 times negative 5, and that would be 30. Minus 21, negative 21 times 4, which is negative 84. So minus negative 84 divided by negative 57. So we simply add this. In this case, we add 30 minus negative 84. You add that, and that would be positive 114 divided by negative 57. So negative 30 minus negative 84 is 114. And you divide that over negative 57. And that equals 2, negative 2. So to find the value of x, we know that x is negative 2. Now we're going to do the same thing to find y. X is negative 2. Okay, so now to find y, we do the same thing. We plug in the numbers into the formula, and we say 9, which is a, because the formula says AECF, so 9. And it would be E, which is negative 6. And we have C, which in this case is 3. And D, which is negative 5. Over the determinant, which is negative 57. And now we do the same thing. We find the determinant and then divide it by, in this case, negative 57. So that would be 9 times 5, or 9 times negative 5, which is, I'm sorry, I made a mistake here. Excuse me. I made a mistake. Give me 1 second. It is actually F, so that would be 21. Negative 21, pardon me. Let me fix that real quick. So I'm sorry, this is not negative 5. It would be 9, negative 6, 3, which is C, and F is negative 21. Pardon me. So we're actually going to multiply 9 times negative 21. And the value, or the answer, for 9 minus 21 is negative, or times 21 is negative 189. So this is negative 189. And 3 times negative 6 is positive. I'm sorry, 3 times negative 6 is negative 18. So minus 18 divided by negative 57. Divided by negative 57. Minus negative 18. Give me 1 sec here. Sorry. Minus negative 18 minus negative 18 over negative 57. So obviously, negative 189 minus negative 118 the negative sign turns into a plus. So in reality, this would be negative 189 plus 18. And negative plus a positive I subtract. So my answer is negative 171. So this equals negative 171 over negative 57. And when you divide negative 171 over 57, that equals positive 3. So our answer is 3. And then that means that the solution, or the ordered pair, for this system of equation is negative 2 and 3. And that would be the answer. So technically, if I wanted to check this answer, I could just plug the negative 2 wherever there's an x and the positive 3 wherever there's a y, and I would get each answer respectively. So that's how we use Kramer's rule to find this answer for a system of linear equation. For a system of linear equations, and for a system of linear equations, and basically, I'm sorry, so you would plug in negative 2 and 3 into that system of linear equations, and then you would get the same answer. So the next example that we're going to see is using Kramer's rule, but instead of a 2 by 2, we're going to see a 3 by 3. So let me go ahead and clear all the drawings. And then let's look at your book. I'm still in your textbook. More specifically, I am on page, I believe it's 206. And let's look at a system of linear equation when you have 3. So let's say we have a system, and it's the same rules. It's just that now we have an extra variable that we need to take into account. So we say ax plus by equals z. And dx plus ey. Oh, I'm sorry. Plus cz is what I meant to say. Plus cz. So let me undo this. Plus cz equals j. And the other is dx plus ey equals fz, or plus fz equals k, and the last equation is gx plus hy. Gx plus hy plus iz equals L. So again, this is Kramer's rule. Let me write that down. Kramer's rule a 3 by 3 matrix. Continue. So just it's very similar to what we did in our previous example. Um, and then if we were going to look for the coefficient matrix, it would be A, B, C. A, B, C. D, E, F. G, H, I. So basically, we would find the determinant of these, of this, and then um, we would find x, y, and z. So if we were looking for x, we would say x equals JBC over KEF JBC KEF and LHI over the determinant of A Y would equal AJC AJC KEF LHI. I'm sorry. I apologize. I realized I ran the right or wrong one. AJCDKF. Let me fix that. DKF. Half. GLI over the determinant of A over the determinant of A GLI, and I apologize for this taking so long, but just getting the Zoom to cooperate with me and to find the Z, because this is a 3 by 3 matrix. Z would equal ABJ A, B, and J over DEK over GHL, excuse me, over the determinant of A. And we're going to see a story problem real quick to help us work with this 3 by 3 using Kramer's rule with a 3 by 3 matrix. So this story problem, which is on page 206 of your book, says the atomic weights of 3 compounds are shown. Use a linear system and Kramer's rule to find the atomic weights of carbon, hydrogen, and oxygen. So we have the compounds, and we have glucose, which is C6H12O6. So this story problem, they want us to use Kramer's rule to find the atomic weights, in this case, of glucose, which is C6H12. H12, C6H12O6. And then we have, and the atomic weight is 180. We have carbon dioxide, or CO2, which is the next one. And the weight is 44. And the other one is hydrogen peroxide, H2O2. And the weight is 34. So what we're going to do is we're going to set up a linear equation, and we're going to separate the compounds. So we're going to say for carbon, for glucose, we're going to say 6C, which means 6 carbon, plus 12 hydrogen, plus O6, and that equals 180, or plus 6 oxygen, excuse me. Here it is, 6 oxygen, and that equals 180. Now we're going to set up our equation, our second equation, which would be carbon. So we're going to put a 1 over each other. So in your book, they just wrote the letter C. You could write 1C, and it really won't make much of a difference because it has 1 carbon. It has no oxygen, no hydrogen, plus 2 oxygen. So your book doesn't write it, equals 44. But if you want to keep things aligned, it has no hydrogen, and you would represent that in the equation as 0H and the last part of the equation says 2 hydrogen. So here we have 0 carbon, 2 hydrogen, and 2 oxygen. 2 oxygen, I'm sorry. 2 oxygen equals 34. So what we want to do is we want to find the determinant. So the determinant is A, B, C, or D. So what I like to do is first label them. So this is A, this is B, this is C, and this is J. And then this would be D, E, F, and K. And then this one down here would be G, H, I, and L. So labeling them just gives me a visual more of, like how to organize them. So I'm actually going to go ahead and erase this part here of the equation so that I can find the determinant. So now finding the determinant of a 3x3 matrix, well, we simply write and we say, well, that would be 6, 12, and 6. And then over 1, 0, and 2. And then 0, 2, and 2. And what we do now is we write the first 2 columns. So we say 6, 12, 1, 0, and 0, 2. Now we can find the determinant of this matrix. Okay, so let's go ahead and do that. And what I'm going to do real quick is change the color. So if we're looking for the determinant, we say 6 times 0 is 0. And of course, 0 times 2 is also 0, so that would be 0 here. Plus, we do the same thing. 12 times 2 times 0 is also 0. And then 6 times 1 times 2, which is 12. So obviously, this is going to be 12 when I add everything up. Now, I'm going to do the same thing on the other side. 2 times 2. I'm sorry, 0 times 0 times 6. 0 times 0 times 6. And that would be 0, so minus 0. And then here I already did it, which was 2 times 2 times 6, which is 24. So plus 24. And here we would have 2 times 1 times 12, which is also 24. So obviously this other side would equal 48. So you have 12 minus 48. Which equals negative 24, negative 36, excuse me. So that is the determinant. Now that I have the determinant, all I need to do is plug in the numbers. So let's look for x, y, and z. So I'm going to go ahead and erase this. Let's look for x. If I'm going to look for x would equal JB, and x would equal J, B, and C, which in this case would be J, B, and C would be 180. My 12 and 6, sorry. And then the other one would be K, E, and F, which in this case is 44, 0, and 2. (44, 0, and 2). And lastly, the other one would be GH or LHI, which in this case would be 34, 2, and 2. Two and 2. So let me go ahead and erase this here so I can have the extra space. You can always pause and rewind just in case you miss something. And now let's write the other two columns. So the other columns would be 180 and 12. 44 and 0. And 34 and 2. All that over the determinant, which is negative 36. So we're going to find the determinant of the matrix. We'll find the determinant of the matrix, which basically we do by multiplying, for example, 0 times 180 times 0 times 2, which is 0. And then we have 12, 2, and 34, and 6, 44, and 2. And then we do the same thing here with 34 times 0 times 6, and 2 times 2 times 1, and finally 2 times 44 times 12. So when we do that, when we multiply, remember how we, and I'm not going to go over the details of the determinant just because I'm trying to save up some time, but pretty much remember, basically I multiply across on each term like I did here, and then I add them and then I subtract them. So our final answer when we look for the determinant of this value is actually negative 432 over negative 36. And that is going to be positive 12. So this is going to equal to 12. Now what I'm going to do is, just to hurry up, I'm going to write or skip through some of the steps. If we're going to look for the other value of the determinant, we would say 6 180 to find the value of y. We would say 6 180 remember, to find the value of y would be a, j, and c. So a, j, and c would be 6 180 and 6. And then over D, K, and F, which in this case D is 1, K would be 44, and F would be 2. And then over G, L, I, so that would be G would be 0, 34 and 2, G would be 0, L would be 34, and I would be 2. And the determinant we found was negative 36. Okay, so I'm going to go ahead and erase this side here just so we can have some space so you guys can see. So let me go ahead and erase all this. The ones with the 3x3 are definitely a little bit longer than what we saw with the 2x2s. And the process can be a little bit, especially with this new digital method, a little bit tedious writing all these numbers down. But it's not really difficult. So we know we have 6 and 180. 1 and 44. 0 and 34. And the determinant is actually negative 36. So let me write that a little bit better. 36. So the same rules apply, ladies and gentlemen. So we multiply 6, 44, and 2, 180, 2 and 0, 6, 1, and 34, and then 34 and 1 and 6. And we skipped one, so 0, 44, and 6. I'm sorry, 31, 4 times 6, and then lastly 2 times 1 times 180. So remember that determinant of a 3 by 3 matrix is basically I multiply them across, and then at the end I subtract, what I got from the multiplication of these 3 in a row minus the multiplication that I got from these 3 in a row. Okay, so in that case, the total value of that determinant is negative 576 over 36. Or negative 36, excuse me. And the value of that determinant is 16. And now we're going to do the last one, which would be technically the value of z. So with z, our matrix would be A, B, and I. One second, ladies and gentlemen. I made a mistake here, guys. Pardon me for the error. I made a mistake here. Pardon me. When I did the multiplication wrong. So technically, when I multiply all these together and I subtract, I actually get negative 36. So actually this, ladies and gentlemen, is negative 36, which equals 1. And I apologize for the error. So again, let me spotlight that. Basically, when I multiply 6 times 44 times 2, and then 180 times 180 times 2, or excuse me, 180 times 2 times 0, I get 0. And then 6 times 1 times 34. And then when I multiply that by 0 times 44 times 6, 34 times 2 times 6, and 2 times 1 times 180, the answer I get is negative 36 over 36, which equals positive 1. Now, I'm going to find the value of z. I apologize for the mistake. Making sure. Okay, so now I'm looking for z, and z is actually A, J, and C, which would be the matrix I'd be using, A, J, and C, which would be 6, 12, and 180. And D, K, and F, which in this case would be 1, 0, and 44. Over 0, 2, and 34. Over negative 36. And of course, we find the determinant. We say 6 and 12 1 and 0, 0 and 2. And that would be 6 times 0 times 34, 12 times 44 times 0, 180 times 1 times 2, and then on this side 0 times 180. The other one would be 2 times 44 times 6. Pardon me here. 2 times 44 times 6. And then 14 times 1 times 12. And that would equal negative 576. Divided by negative 36 equals 16. So our answer for this exercise would be 12, 1, and 16. 12, 1, and 16, which states that the atomic weight of carbon, hydrogen, and oxygen are 12, 1, and 16, respectively. Ladies and gentlemen, hopefully this video will be of good use to you. So stay safe, and I will see you in our next class. Bye.